All right, so we this is exciting. This in this assignment, we're going to go over multivariate statistics. So simply put, multivariate statistics are when you have more than one predictor, or as Qualtrics will call it, explanatory variables. If you have more than one predictor in your model at the same time, okay. And when you do this, you're going to get different results than if you just ran those predictors one at a time. And it's pretty cool what happens as we do this, and we're going to go through that as we go through this assignment. And so the first thing that you're going to want to do is to download both of these. Don't open them, right? And then I'm going to, as if I were doing this, create a new project, go to survey, get started. I'm going to name the survey whatever I want, and then I'm going to import a QSF. I'm going to choose a file, and it's going to be the survey that we just downloaded. So it should be the dark house survey. And then once we have that up, let me see if I have another version of this. Here we go. So I'm going to create project. Okay. And so once you've done that, you're going to click yes, I've loaded that. And now for question 2, I'm going to go to data and analysis, wait for this to load. It's kind of crazy how long it takes to load. No data. Okay, so we don't have data here yet, so we're going to import the data. And here's my version of the data. Yours will say dark house data CSV. We're going to upload. Check. It looks like it's taking all those into account, which is great. So we're going to import. And then we are you're just going to give this a little bit for the data to load, and you should be set to go. Once that is loaded, you can answer yes here, and then this is really important. So after this is loaded, and only after, sometimes it helps to refresh the page. Okay, it's starting. You can see it there. So only after this is loaded should you go to the next step, because for whatever reason, okay, and see recorded, I see the data here, recorded responses. I just want this to say 70, so I'm going to refresh this. There we go. So that's done. So now that this is done, now I'm going to click Stats IQ. If you click Stats IQ before the data is loaded, the one thing I really don't like about Stats IQ is it is really slow with updating changes to the data. Okay, so if you click on this before the data is loaded, it will take forever to load Stats IQ, like a long time. So don't do that. Wait for the data to load and then click Stats IQ. Okay. If this takes more than 5 minutes, something's probably wrong. In that case, what I would do is who knows? For some, that's the one problem with using like a web-based software. Every once in a while, something like that comes up. But if that occurs, it's easy just to. This is the survey I just created. I'm going to click here and copy it just to create another copy. You can name it whatever, copy, and then load the data into your newly created copy and try again. And sometimes that helps. Okay, sometimes that'll come up faster than the other one. So so those are a couple things to try. This loaded a lot faster. So sometimes it's like the luck of the draw. I don't know if their server gets busy at one point as you're running it, but yeah. So if this takes a while, that's something nice to try. Okay, so I have my my data loaded here, so that's great. And so if you haven't clicked yes, click yes, definitely now. Let me run through this survey really quick. So this survey, the idea here is that we're testing out, there's a new film, Dark House on 1600. Has like a, there's like an EMP attack, and the White House is vulnerable to mythical creatures that come from the forest or whatever. Totally nerd, but kind of like a fantasy horror film, with the president trying to figure out what to do as these dark, like mythical type creatures come and attack the White House, and nobody has power. So just kind of like a fun film. The idea is that we've run a screening test, okay, and so after the screening test with these participants, these viewers, we gave them this survey where they answered questions. These are just some beliefs that they have in general, not necessarily toward the film, just in general. We can do all kinds of things with this, and we'll do some more in the future. But their beliefs with mythical creatures, how much they enjoy national parks, trust the government, harmony with nature. You can kind of go through these different beliefs. Those go through Q8. Then there's two other questions that are they're asked, like if they were trapped in a bunker during a crisis, what would they choose as their snack? And just a fun one, and that we have there. You could do some things with this as well, and then choose a mythical pet. Okay, so the idea is that if we wanted a collaboration with some snack company to create some type of promotion product, and maybe a combo of a pet, or like chips with a Sasquatch on the front, or a hellhound on the front, or chocolate. We're trying to get ideas for promotional snacks and partnerships there. And so those are kind of fun way of doing that. And then they're asked their opinion on the film, how much they enjoyed it, whether they were on the edge of their seat, if they want a sequel, and then a nice one is we also had some of these are like biometric data, so it's kind of like high tech measurements. So during the film, we were measuring their heart rate. This is our average heart rate during intense during intense scenes. This is our average resting heart rate. Using a camera, we captured the number of times they looked at their phone, the number of times they glanced away from the screen. We used facial coding to see like common facial expressions, the most common facial expression that they had for the film, and we'll be able to get a sense for that too. And then this one we're not really using in this assignment just yet. So okay, so that is the survey. So now that we're done going over the survey, let's take a look at question 3. All right, I'm going to go data and analysis. I'll go to my stats IQ. Here, we're doing just like a regular just analysis with one predictor to start, just to kind of give you a sense as to what's going on here. So in the film, some of the mythical creatures are their role is like as protectors of the earth. And so one thing that you are wondering here is if the viewers' feelings toward that for protecting the environment, if that predicts whether they want a sequel or not. Okay. Or how badly they want to see a sequel. So here, just like what we've done in the past, I'm going to go here to select my two variables and Q13. And this one, we're seeing if Q3 predicted that, if what the role of Q3 is on Q13. So we want the key to be on our outcome variable. We're going to click relate, just like we've done in the past. But what I'm going to do is I'm going to select a different one, just so mine looks a little different than yours, and you'll be able to answer these on your own. Okay, so I'm going to click relate. And I see here that trusting government is positively correlated with they want a sequel. Okay, so I would come here. Here's my p-value. So I see, okay, there is a relationship between trusted government and them wanting a sequel. Since the beta is positive, we're going to say like the more that they trust the government, the more they want a sequel, right? And so this, you may have a similar finding here, or depending on if the p-value is significant or not. Protect environment may or may not be significant. You put the p-value there and the beta there, okay? Now for this next step, it says, so keep that finding in mind, but we want to know, since there are several reasons why a person might want to protect the environment, so, you have like so you want to protect the environment, but you may also think that you want like we should have harmony with nature and not try to control it. There's going to be a group of people that feel that way, but there's going to be some people that don't necessarily feel like, oh, we shouldn't control the environment, and we shouldn't try to, be masters and live in harmony. There may be people that don't necessarily feel that way, but still feel like it's a good thing to protect the environment. Okay, and you may have, for instance, here we have enjoying parks. They like to be out in parks. So that's another one. You may have people that don't necessarily like to go out in parks, but still feel like we should protect the environment. You could have camping comfort, so this is going out and camping in rural areas, like alone, how comfortable they are with that. You may have people that don't necessarily feel comfortable with that, but do still feel like they need to protect the environment. So there's kind of like a lot into all kinds of people might feel like or not feel like they want to protect the environment for different reasons, okay? And what's going to happen is if we run all of these at the same time, I'm going to focus here on protect the environment. What it'll do is it'll show us the impact that protect the environment has on the how much they want to watch the sequel. It'll show us that, but it'll also kind of control for or hold constant kind of these other things. So you're kind of teasing out the role that, for instance, nature harmony was having, was playing between environment protection and the one sequel. It's almost as if we just ran these two together, it's almost as if we're saying, okay, what if nature harmony was the same for everybody? Everybody had the same belief of nature harmony. Then what would be the role of protect environment on want sequel? Okay, so we're like holding these other variables constant, which can be pretty cool. one example that I sometimes give is if you have, say for instance, you had data that was looking at ice cream sales in different areas, and you were also measuring skin cancer victims, so those diagnosed with skin cancer. I'm sure that if you had that data, you would see that areas that had higher ice cream sales also had more skin cancer patients. Would you say, oh, this is kind of is ice cream like causing skin cancer? No, there's probably something else going on there. And so if you're able to um, take that into account, so for instance, the temperature of the area, if you can take that into account at the same time and say, okay, what if the temperature for all of these locations was exactly the same? Would ice cream sales still predict skin cancer patients? Okay, and probably not, because the temperature was probably the thing that was causing this to happen, right? The higher the temperature, the more people are outside getting skin cancer and eating ice cream. All right, so it's a cool way to kind of hold other things constant. So let's look at this. So we have enjoy parks, nature harmony, and camping effort. Okay, so we want to run those and see if they how that impacts the relationship between protect environment and want SQL. Again, I'm going to go trust government instead, just so I get something a little different. So I'm going to run this. Oh, sorry, very importantly. Instead of clicking relate, we're going to click regression, okay? And what regression is going to do is it's going to run all of these at the same time. If I clicked relate, it's going to run individual analyses for each of these predictors on want SQL. But if I click regression, it's going to put it together all in one model, so that all of these predictors are being run at the same time, and they're being controlled for one another. And so what we end up getting here, first of all, this is kind of cool. We can click on each of these for a little description on what's going on with each predictor. So here, trust in government for me is not statistically significant. But the important thing to remember, because if you remember the example I just gave earlier, trust in government alone was statistically significant. But if I run this while also taking into account or like holding constant these other variables, all of a sudden it's no longer significant. Okay, but it does show kind of they can still not be quite significant, but still help explain the model, and so to help explain your outcome, more like here want to see SQL. And so this one is these percentages show like how important each of the variables are. Okay, so I can click here. It looks like this one is significant. You can click on all of these. Usually, in most cases, what we want to do is just click here, and it gives us a really nice output here. Okay. So here I see which ones. Here's my p-values for each of my predictors. I see, okay, these ones are significant. This one's not. So again, trust the government while running these other variables. Trust the government does not significantly predict. Okay, so what I would probably say there, if this was a question for me, then I'd say, okay, but what I found here for trust the government, this significant p-value, that was actually kind of explained by these. It wasn't necessarily trust the government, but there was something going on with these parks. Okay, with how much they enjoyed the park and camping and nature. These are the main drivers here. Okay. Now, if we let's look at, for instance, camping comfort. Okay, so this is a significant relationship, And we're going to interpret this just the same way that we interpret them in the past, since these are all continuous variables. So this is my, but this is going to be my beta here. Before we had to look at like it gave like wrote out a little model and showed like and we had to pull the beta off of there. This is just going to put our betas right here for us, which is nice. But yeah, so this is a positive beta and significant. So what I'd say is like, okay, camping comfort, while we're controlling for these other variables, Q4, Q2, and Q7, looks like camping comfort significantly predicts how much they want to see a sequel, and it's a positive relationship. So the more they're comfortable with camping, the more they want to see a sequel. Okay, these ones though are negative, especially while controlling for these other ones. Nature harmony, that had a negative beta. So as the more that they enjoy harmony with nature, the less they want to see a sequel, while controlling for or holding these other variables constant. Okay, and so right here, what we're going to want to do is we're specifically looking at protect environment. So for me, that would have been like the trust the government. So protect the environment. You want to look at, okay, does it, what is what's that p-value, and what's the beta? Is it significant? And if so, is it a positive relationship or a negative relationship? And then and so yeah, you click that, list the p-value there, and the beta there. Okay, so that's question 3. For question 4, we're gonna run some different variables all at the same time. We're looking at these like high tech variables. Okay, we want to see which of these were the strongest drivers and how much they enjoyed the film. So I'm gonna kind of unselect all of these. I'll select all of these here and enjoy film. This one's my outcome. I'm going to make sure that has a key. But for my example, I'm going to do want sequel. Okay, so that mine's just a little different than yours, so I don't give away all the answers. So I'm going to click regression. I almost clicked relate. I would have put up a lot of different analyses. Okay. All right. So here, it's going to be mostly the same thing as what we did. The main difference here is we're now dealing with, there's a categorical predictor here, so we're going to need to know how to deal with that. The rest of this is going to be pretty similar. So if you see like common facial expression, that one's categorical. I want to show you what to do in this case. Okay. So again, same thing. We're going to see relative importance. It's going to tell us which one's the most dominant. It looks like common facial expressions, 80%. That's really high. And so I'm going to click here. I'm going to get the p-values for all of my predictors. Here's all the continuous predictors. But if you notice, the categorical predictor looks a little different. Okay, these are all the facial expressions: scared, happy, excited, bored, confused. And if you notice, here's a baseline. Okay, so what we want to do is, depending on how the question is worded and what we're going to want to choose one of these as our baseline. All right, and it's depending on what we want, because what the baseline does is all of these p-values. Once again, it's while we're controlling for all of these, right? What these p-values are showing is the difference between each of these categories from the baseline. So for instance, this p-value here is saying, okay, the difference between those who were scared versus those who were excited is not significant in how much they enjoyed the film, right? Or in my case, want the sequel. So there's no significant difference there for those two. Again, while holding all these constant, it looks like there is for happy, right? So this is positive, which means happy is going to be higher than excited, or in other words, those that had happy expressions enjoyed the film more than those that had excited expressions, while controlling for or holding these other ones constant. And here, these are negative betas, so we have significant p-values and negative betas, so those who had bored expressions enjoyed the film less than those that were excited, and those who had confused expressions enjoyed the film less than those excited while holding these others constant. Okay, that's the idea here. So in this case, the most important driver was, so you're going to select the most important driver. And I have this set up so by default, I think excited is going to be the one that comes up by default. So make sure that's the case for you. These answers are going to be based off of excited. So relative importance of, I'm going to list that here. I don't see an 80 because I have a different outcome than you. Okay, so you select there. The least important driver was, so to get the least important driver, I'm going to click up here because it doesn't really show them until you click like that box. It just kind of groups all the ones that didn't really play a role up here. So if I click this box, I see heart rate resting for me is the least important. So I would select heart rate resting, and then for me it's 1%. You could do whatever you're seeing there for yours. And then while comparing the impact of the various expressions within this model, you find that those with the confused facial expression, okay, so we're looking at confused, so I'm gonna go here and select confused for mine. Okay, and what we're gonna do is we're gonna change the baseline. So first I'm gonna click confused, and I'm gonna click apply. And what this is gonna now show me is it's gonna compare all of the other facial expressions to confused. Okay, so in this case for me, I'm seeing positive betas here. These are significant. There's a negative beta here for bored. So I'm seeing, okay, so those with scared expressions enjoyed the film more than those with confused. Same with excited and happy. They all enjoyed the film more than those with confused expressions. But bored, this is still significant. So those with bored expressions enjoyed the film less than those with confused expressions. And again, that's while holding all of these others constant, okay? So so for me, I would answer, I don't know if my answer will even be in here. Doesn't necessarily look like it. For me, those with the confused expression enjoyed the film less than everybody but bored, and they significantly enjoyed the film more than bored. So that one doesn't appear here for me. Okay, but you can see like was it less than only excited and happy, more than only excited and happy? Did it not significantly different from any of these? Or did they enjoy it more than all other expressions or less than all other expressions? So you can answer that how you see fit. All right, so question 5. What we're doing here is this will help illustrate what happens if our outcome is categorical. So mythical pet, this is their choice of a mythical pet. We're going to see what to do in that case. So we want to test whether these variables, how much they enjoy the film and want a sequel, and their heart rate during intense scenes, how that impacts the likelihood that they choose various mythical pets. So I'm going to select those variables. Let's see, we have, oh, heart rate intense, I'm going to keep that one. Then we have Q11, Q13, and Q10. Q10 is my outcome, so I would select it just like that. Now, for me, I'm going to make a change here so that mine's just a little bit different than yours. And then I'm going to click, so I'm going to have edge of seat instead of want a sequel. I click regression. Okay, so this is all going to appear identical to what we've seen before. Mine's saying edge of seat is the most important, however, it's not significant. But I'm going to click here on this model to see what's going on here. Okay, so right here, these are going to be my p-values for each of my predictors. But what this is going to do is this is going to show us the odds that each of these predict a certain outcome. Okay, so our outcome is now categorical. And so right now, this little button here is we can select different categories within this variable. Okay, by default, it looks like that none is what's selected, and so these are the odds that that they would not have chosen a mythical creature. None. Okay, so I'd see that edge of seat did not have a role in like the odds that they would not choose a mythical creature. Heart rate seems to. We want to look at this. This is different. This is interesting. This it's rounding it a little bit. Looks like odds are 0.996. What we want to pay attention to, how we're looking at these odds, the coefficient, the beta here. This is going to help. Okay, so you see that this is negative. And the odds, if they're less than 1, it's going to be negative, which means that as that variable increases, it's going to lower the odds that this category happens, that something here happens. Okay, so right now I'm seeing these two are significant. So as heart rate goes up, it's going to lower. This is rounding to being lower than 1, so it's going to lower the odds that they didn't choose a mythical creature. Okay, as their enjoyment of the film increases, it's going to lower the odds that they didn't choose a mythical creature. Okay, and then I'm not seeing anything here for this one. All right, so let's say you find that those that enjoy film and want sequel and heart rate, the likelihood that the mythical pet was fairy. Okay, so here, I would choose fairy, and then I would click apply. Wait for it to load. Okay, now it's going to show me the odds that each of these predict that they chose a fairy. Okay, in my case, they're not significant. None of these statistically predict whether they choose a fairy. Okay, let's say that these were significant though. Then I'm looking at this is lower, and there's a negative beta here. So I'd say, okay, as the more that they're on the edge of their seat, the less likely it was that they chose a fairy. The odds, it decreased the odds that they chose a fairy. This one, it's a positive beta. It's so close to 1, but that's why they're not significant. But it's a positive beta. So I'd say if it were significant, then I'd say the more they enjoyed the film, the more likely it was that they chose a fairy, or it increased the odds that they chose a fairy. This one's negative, so I'd say the higher their heart rate, the less likely they chose a fairy, right? And that's all while we're, for heart rate, we have this finding while controlling for Q12 and Q11. And then if I want to do that for gnome, I can do that for gnome, click apply. And here I'm seeing that, edge of seat, not significant. There is significance here for heart rate intense. I'm also getting marginally significant impact here. It's not quite below 0.05, but it's at least below 0.1, which means there's at least a 10% likelihood that this is due to chance, lower than a 10% likelihood this is due to chance. So this is almost significant. It's marginally significant. So I would take that into account, and I bet that some of these, yeah. So if it's significant or marginally, we want to take those into account for these questions. So sorry for what I had before. None of these predicted my fairy. But for the gnome, and again, you're going to have different answers here. But for my gnome, I'm seeing the edge of seat did not, which that edge of seat is this one for me because I changed it. And then want sequel. Oh, I've changed a couple of these. Huh? So want sequel, that one would be enjoy film, probably. Oh, no. Oh, enjoy film. There we go. Want sequel is my edge of seat. Enjoy film, for me, this is marginally significant. I'm getting a positive beta, so the more they enjoyed the film, it increased the odds that they chose a gnome. And then for heart rate, this is significant, positive here, so the higher the heart rate, increased the likelihood that they chose a gnome. Okay. So that would be my answers here. Yours again are going to be different, but that's how we would go about this if our outcome was categorical. Okay, we want to look at the odds of each of these categories happening. Okay, question 6 is pretty easy. We want to see if any of these questions, Q1 through 8, if they predict heart rate. Ooh, yeah, so that's how I would set this up, and then it's just wanting to know the relationship here, right? This one's pretty easy. I'm just gonna grab like maybe half of these just to show. You should definitely be able to do this based off of what we've already done. I'm gonna go explore model. Here's my p-values. For me, none of these significantly predict heart rate intense. So if that's you would say does not predict on all of them. But if they do predict, then we're looking, okay, if it's a positive beta, they increase. So the more they watch horror movies, the more that the higher their heart rate. All right, so that's a positive relationship, and the negatives are going to be negative betas. So, and that's all while controlling for all other variables in the model. All right, so last question. This is kind of I did this one as this is like a thinker. I really want to help you interpret better what's going on here with multivariate statistics. So here we want to start just by looking at using mythical pet as an explanatory variable and enjoy film as our outcome. So mythical pet, enjoy film, that's my outcome. I'm gonna change mine to want sequel, so it's a little different than yours. This one we're just gonna click relate. We only have one predictor, so we're gonna click relate this time. This from what we did last time in class, it's gonna run an ANOVA for us. I'm seeing here that there is a significant relationship Here's my p-value, my initial p-value. So I would put that here. In this case, that matches here. Specifically, you find that those who did not choose a mythical pet, the none, enjoyed the film significantly or marginally less than blah. So again, so just because there's a p-value doesn't mean that all of these groups, so these are the averages on how much they wanted to see a sequel for me. It doesn't mean that all of these significantly differ from one another. I gotta go to the pairwise comparison, and I look here, and this is wanting me to really just look at those in the none group. So here I see, okay, they significantly differ from Sasquatch. I can see here they're the lowest for me here, but I don't know if they significantly differ from all of these. So I'm just gonna sort here, look at my nuns. Yeah, it looks like the nuns all are significant. So as I compare fairy to none, significant, gnome to none, significant, hellhound to none, significant, and then the first one I looked at, Sasquatch and none, that's significant. Okay, so none is significantly less than all other creatures. Okay, now what's interesting is if I'm looking at this, I see that no other comparisons are significant. Okay, so yeah, this is a significant relationship, but looks like for the most part it's being driven by none. So those dorkwads that are like, I'm too cool for school and didn't want to choose a mythical pet, like weirdos. So so that seems to be kind of what's going on here. So I might wonder if that's the case. So here I would put no. So I don't have mine. I would say like all groups. Here, okay. So I don't have that. So I'll just go. That seems the closest to what I'm seeing here. So what we may wonder is, okay, is this that they're what is driving this? Okay, is it just that they just didn't feel like picking a mythical creature, or is there something going on? Is there something like those that were picking mythical creatures? Maybe they had like higher beliefs in mythical creatures, and that was what was driving this. It's not necessarily whether or not they chose a mythical creature, but there's something going on in the background here. And so what we're going to do is we're going to say, okay, to test this, maybe my theory is that, hey, what's really going on here is these people that have didn't choose a mythical creature, they enjoy the film less because they maybe have less of a belief. Maybe if I measured like passion for the mythical, topic or whatever, I don't have like the passion for it, but I at least have belief. So what are their beliefs toward mythical creatures? And maybe that something like that is driving this result. So if I want to test that, what I could do is say, okay, well, what if we controlled for people's beliefs in mythical creatures? If that predicts what's going on here, and if I run that in the model at the same time, and I'm no longer seeing these differences here, something's going. That probably means that this effect, what I'm seeing here, is explained by their beliefs in mythical creatures. Okay, so I'm gonna run this. And this will help illustrate it. Again, I have a different outcome than you. Okay, so for me, I'm seeing a mythical pet is pretty high up there in importance. I'm going to click here on the model. And so this one specifically is asking for, as your outcome, and find that those who did not choose, so you want to make sure that none is selected here as a mythical pet, blah, and then we're going to look at these results. So for me, I see mythical beliefs significantly predicts and it looks like none. It significantly differs from all other groups. These are all positive. So it looks like while controlling for mythical beliefs, those in the none category still enjoyed not enjoyed, but wanted a sequel less than Sasquatch, Gnome, Hellhound, and Fairy. Right? Since these are positive, this was more and more than none. Okay, they were higher. And so I'm seeing here for me, it doesn't look like that my theory is coming true here, because these all significantly predict still. It doesn't look like that effect that I saw here is being explained by their mythical beliefs. So for me, I'd say less than all other groups. And then I'd say at the same time increases, then for me, I'd say it's not explained by their belief in mythical creatures. So that's what I'm seeing there. So I hope this helps you with understanding what's going on with multivariate statistics and what happens when we add more predictors. And it's pretty cool. It's nice doing this here in Qualtrics. It helps illustrate this in an easy way. But as always, reach out to me if you have any questions with this at all.